Hello, party people. Get ready to clap. Woo! Welcome to the ChaosWest stage, where now Jeremy Rand, the chief developer of an amazing coin called Namecoin, will talk about even more amazing stuff. Please have a no, don't clap right now because we just had. Jeremy, the floor is all yours.
Thank you. All right. So I'm Jeremy Rand, lead application engineer of Namecoin. Does this work? There we go. Okay. So for those of you who aren't familiar with Namecoin, the brief one-slide introduction is think DNS, but secured by a blockchain. We are using the .bit top-level domain. We're the first project that was forked from Bitcoin way back in 2011. It uses special coins in Bitcoin terminology to represent names. We originally started out doing censorship resistance as the primary use case, but more recently we realized that privacy was a really important use case as well. And so we started doing things with TLS because we thought TLS could use some blockchain love. So for those of you who aren't familiar with how the certificate authority system works in TLS, so TLS is the protocol that is used for authenticating websites that use HTTPS, among other things. And TLS relies on these corporations called certificate authorities, and these certificate authorities have the ability to misissue certificates if they choose to, or are forced to, or do so accidentally, that can impersonate websites. And this is really, really bad. Sometimes they've been compromised by people who maybe were affiliated with Iranian intelligence agencies. We don't really know details. And sometimes certificate authorities just are totally unethical companies. There's a certificate authority called Startcom, which basically tried to hold the entire internet hostage during the Heartbleed crisis a few years ago. And they suffered pretty much no major repercussions for that action. So we'd really like to get rid of certificate authorities completely, or at least as much as we can. So there have been a lot of projects proposed over the years to try to get rid of certificate authorities or replace them in some way. And a sampling of them is up here. One of the better known ones is called Convergence. It's by Moxie Marlinspike. And the idea of Convergence is rather than having to trust certificate authorities that are chosen by either the website or the attacker impersonating the website, the user gets to choose which trusted parties they want to authenticate websites. And this is called trust agility. And it's a legitimate idea, but there are some problems with it, as I'll get into later. Another project that exists is called Dane, which uses DNSSEC to replace certificate authorities. The idea being if you can securely get information about a domain name, then you can verify what certificate is valid for that website. And there are a few other projects out there that are trying just to limit the amount of damage that a malicious certificate authority can do. So these are things like HPKP, which is public key pinning, things like certificate transparency. So there's a lot of projects out there that are trying to fix the certificate authority issue. But what's missing in all of them is the problem is all of those solutions that try to mitigate the problems of certificate authorities, they don't fix the underlying problem, which is that there are still a set of trusted parties who have the ability to man in the middle a TLS connection, at least at some point. They may be detected later, but at that point it may be too late. So what we'd like to do, ideally, is make sure that no one is able to impersonate a website via man-in-the-middle attack, and that if they try, we want to be absolutely certain that it will be detected during the TLS handshake, and we don't want any trusted third parties for this. So the idea here is actually a fairly old one. As I mentioned earlier, Dane is a project that actually is very superficially similar to what Namecoin is trying to do here. The idea that Dane had is that if you can securely get information about a domain name using DNSSEC, and you trust DNSSEC, then you can just get a TLS certificate fingerprint over the DNS, and then you're good. You can just verify based on that. And you know, this has been standardized by IETF. It's a reasonable spec. The problem is, do we really trust DNSSEC? DNSSEC is controlled by the ICANN root key and all of the DNS registrars and registries. That's a lot of trusted parties as well. So, you know, this may not really be ideal. But on the other hand, maybe we do trust Namecoin because it's backed by a blockchain to actually do what DNSSEC tries and possibly fails to do. So at least in theory, this should be fairly straightforward. The idea would normally be that you have Namecoin just put DNS records which match the records in the Dane spec, and then it should just magically all work. Namecoin is interoperable with DNS pretty much completely. So the problem here is it really is not that simple. And I'll get into that in a moment, but basically, in theory, you can even sign Namecoin records with DNSSEC using a local DNSSEC key. So anything that speaks DNSSEC and knows Dane should be able to handle this pretty much transparently. The problem is that there aren't any web browsers that know how to use Dane. And as a result, we can put secure DNS records into Namecoin that talk about TLS fingerprints, but that just isn't going to be read by any web browsers that exist. And so there are some proposals in the web browser development community for having those Dane DNS records just attached in the TLS handshake as part of a stapled record. The problem with doing that is that in order to sign Namecoin records with DNSSEC, the DNSSEC key is going to be generated on localhost. So the remote server is not going to know your DNSSEC key. It's not going to be able to work for that. And so that approach, which by the way also still isn't actually implemented in any web browsers, that doesn't work either. And unfortunately, the Chromium security team in particular has completely refused to even entertain the possibility of allowing, for example, browser extensions to customize how TLS works in any way. So there are a few methods that exist out there which can be used to sort of coerce a TLS implementation like a web browser into totally customizing how certificate validation is done. The most well-known and probably most dangerous method is called an intercepting proxy. This basically is a proxy that terminates TLS coming in and creates TLS coming out. So the problem here is that that means the proxy has to do everything TLS related on its own. And if you remember the Lenovo Superfish bug that was in the news a while back, the reason Superfish happened was because Lenovo was running an intercepting proxy, and they made a mistake in how they implemented it, and it totally broke the security of the system. And so from our point of view, we don't think that intercepting proxies are really an acceptably safe way to customize how TLS works, even though they are very flexible and they would do what we want functionality-wise. There's also browser extensions that do exist. There's one called DNSSEC Validator, which actually claims to support Dane in web browsers like Chromium and Firefox. The problem with that is that just sort of on a whim, when I was taking a network security course at my university, I said, hey, for my midterm project, can I audit DNSSEC Validator and see whether it actually is secure at all against man-in-the-middle attacks? And my professor said, okay. And so I audited it. It took me about 10 minutes, I did a man-in-the-middle attack using a local proxy, and I looked to see what DNSSEC validator would do about it. Well, it did pop up with a warning that said, hey, this is the wrong certificate. The problem is it did that after my login cookies had been sent to the attacker, and after the sensitive information from the server had already been sent back and captured by the man-in-the-middle attacker as well. So, you know, I mean, the underlying problem here isn't so much that the DNSSEC validator developers have a problem, it's that the browsers just don't offer good APIs to do this securely. So the DNSSEC validator developers were working with the best thing they were given, but the approach of using a browser extension just doesn't work right now. There's also something called CertShim, which uses this fun shared library LD preload magic, which can basically override the functions in a certificate validation library that validates certificates. And that kind of works. The problem is, to do that, it's using data structures, which are just C structs, that are not part of any public API. And if, you know, if OpenSSL or NSS or some library like that changes that internal data structure in an upgrade, then all of a sudden CertShim would be messing with the wrong data. And as far as I can tell, there's no way to be sure that wouldn't lead to some kind of dangerous memory corruption. And so I really don't think that's very safe. So all of those existing solutions had a lot of problems. And we basically decided, let's try something totally different. So something to keep in mind here is there are actually two different problems that need to be solved here, which we refer to as positive and negative overrides. So basically, if there's a self-signed certificate that does match what the blockchain says, we want that to be accepted even though it's self-signed. But also, if there's a certificate that's valid according to a certificate authority, but doesn't match the blockchain, we want to make sure that gets rejected. So there's two problems here we have to solve. And it turns out these two problems are actually almost entirely orthogonal in how to solve them. So you may have noticed that you can just add a certificate to your operating system's trusted certificate list, and then that gets accepted by your web browser, even if it's self-signed. But this is a really, really dangerous idea for lots of reasons. Most majorly, just that if the certificate is valid as a certificate authority, well then, when you insert that, then the attacker who controls that certificate that you got, say, from the Namecoin blockchain, they now have a malicious certificate authority that is on your system. They can now impersonate everything. And generally speaking, certificates, they follow the X509 spec. X509 is incredibly complicated. None of us felt up to the task of trying to audit every single attacker-controlled certificate automatically to see if it had anything dangerous in it before we inserted it into the trusted certificate list. And so, you know, we kind of didn't like that. And there's also, of course, the problem that a certificate is actually pretty big. Ideally, we just want a public key hash, because that's really small and fits in the blockchain easily. Fitting an entire certificate into the blockchain is just prohibitively expensive. It wouldn't scale. So those are the problems that we encountered there. So this is a chat log from a conversation I had with our lead security engineer, Ryan Castellucci. And basically, as you can see, Ryan asks, how small can we actually make that certificate? And I said, well, probably not small enough. And then Ryan says, let me do some wizarding. And then he comes back a few minutes later and he says, yeah, we can actually make it fit if we cheat. So what is this cheating he refers to? The idea is that you have this concept called a dehydrated certificate. And the idea is the data you put in the blockchain consists of a very, very small subset of the fields that are valid in a certificate. So all you're putting in is the public key, the signature, the start and end date for the validity period, and also, of course, there's the domain name itself that it's valid for, which isn't even specified by the attacker. The browser knows that because that's what it looked up. And So we're also using ECDSA rather than RSA, because ECDSA is, of course, a lot smaller. And this actually scales really, really well. So if you compress a binary certificate by dehydrating it, you wind up going from 464 bytes to 104 bytes. So it's really good a level of compression. A Namecoin name can store up to 520 bytes. So this fits reasonably comfortably. In practice, we had to add some bytes because we're encoding it as JSON, and we couldn't use compressed public keys because libraries didn't support that very consistently. But yeah, in terms of scalability, this works great. That solves the scalability issue. But what about the security issue? Well, it turns out that this actually solves the security issue as well, because none of those fields that the attacker controls, things like the public key or the signature, none of those can actually be used to make the certificate valid in a totally different context than it was expected to be used in. Basically, if the attacker tries to dehydrate a certificate that's valid for something it shouldn't be valid for, the signature is not going to end up matching, because when it gets rehydrated, it gets filled in from a template. The template won't match what it originally was. The signature check will fail, and you'll get a certificate error. So Ryan came up with the math behind this. I'm the one who actually implemented it. And I didn't want to use OpenSSL for this, even though that's the standard toolkit you would use. I just don't trust OpenSSL. Their API is impossible to use properly, as I'm sure we all know. I also don't really trust C or C++ code very much for memory safety issues. Conveniently, Namecoin's DNS bridge software uses Go, and Go has a really, really nice X509 processing library. And so we went with that. There were some issues because Go's X509 library is actually a little bit too high level. There was no good way to actually splice a signature into an existing certificate. I ended up having to do some mildly weird stuff with a script that automatically would copy the standard library version of the X509 library into a new package, and it would then add a function that could do the splicing using private functions. So, I mean, it kind of made our hair crawl a bit, and it's not the cleanest thing out there, but it does work. So from this point, what we ended up doing is when we get a DNS request for a Namecoin domain name, which gets processed by code that we control on localhost, instead of replying immediately with the data, we insert that TLS certificate that we've rehydrated into the trusted certificate list, and then once we've done that, then we reply with the DNS record. And this actually works surprisingly well because it turns out that both Crypto API in Windows and NSS on Linux, they actually, those things we inserted take effect immediately. So you don't have to restart the browser or anything like that, which was kind of surprising. That said, Crypto API on Windows has lots of stupidity in its design. Among other things, it normally wants you to be an administrator to actually add a certificate. And it's also really slow for reasons I couldn't figure out. And even if it weren't slow, running as administrator is not that safe. So turns out that Windows Crypto API actually stores those certificates that you add to it in the Windows registry as binary blobs, which is a little bit odd, but it is Microsoft. They love the registry. And of course, to make things worse, it's not even a standard DER encoded binary blob. It's a special encoding that Microsoft made. And while I was reverse engineering what it did, I realized the reason they did that was because they wanted to cache the results of hash function evaluation. Note that they're not caching the results of RSA or ECDSA, which are hundreds of times slower. So I don't know why on earth Microsoft made this so complicated. But in any event, I did successfully reverse engineer how those certificates are stored in the registry. The Windows registry has a permission system with standard ACLs, just like the file system. So we don't actually need to run as an administrator anymore. We can just create a separate user that has access to that exact registry key, and that all works. And here you can see a screenshot. I'm not sure how visible this is from where you are, but this is a screenshot of a Namecoin domain name with HTTPS, and this is Chromium saying that yes, it verified successfully. So that was the positive overrides. Now we move on to negative overrides. And actually it turned out that this was a lot easier than trying to do the positive overrides. At least it's easy with some caveats. The trick here is that we're abusing HPKP, which is the public key pinning spec in web browsers. So normally, if you're not familiar with how HPKP works, basically a website can opt into having a whitelist of acceptable public key hashes for its TLS connection. And if it doesn't match, you get a public key pinning error. And this is rather interesting because when HPKP was being written as a spec, a lot of people were like, hey, wait a minute, what if I want to intercept my own TLS connections? And so what the decision was that, okay, you can intercept your own TLS connections because if you add your own certificate authority to the trusted certificate list, it will actually not be subject to HPKP. And the logic there actually makes sense, because if an attacker has the ability to add arbitrary certificates to your trusted certificate list, then probably they have a lot of access to your machine. They can already do horrible things to you. But wait a minute, that means all these certificates we added as positive overrides are exempt from HPKP. Can we use that for something clever? So let's say we take the domain name bit, which is the top-level domain that Namecoin uses, and we set a public key pin on that, including all subdomains. And we just set it to a public key hash that no one has the private key for. Well, then all of the certificate authorities that are trusted by the browser by default, they won't be able to issue any certificates for it because it won't match the public key pin. But all of the things we added as positive overrides are exempt from that. So as a result, the self-signed certificates that we're adding that came from the blockchain via rehydration, those will work. But if it's signed by a certificate authority, it won't work. So that solves the issue there. And in particular, we ended up using, as the public key hash, Ryan suggested to use 1/pi scaled to 256 bits, which seems to be fairly good as a nothing up my sleeve value. And it turns out that Chromium actually stores all this data in just a JSON file with all of the key pins. And so it's trivially easy to make an installer for Namecoin. Just edit that JSON file when you install it so that the key pin gets put in place. And so this is an example of what it would look like, hypothetically, if a malicious certificate authority issued something that it shouldn't for a Namecoin domain. Now here you'll see it's google.com because we tested it by setting the key pin on com rather than bit. But yeah, this basically demonstrates what would happen if someone misissued a certificate for a Namecoin domain name, even if they're a trusted certificate authority. It will not be allowed, and it will say pinned key not in cert chain. So that solves that problem as well. There is a problem though here. You might have heard that Chromium is deprecating HPKP soon. It's expected HPKP will be removed from Chromium sometime early to mid next year. So what are we going to do about that? On Windows specifically, Windows itself actually has a key pinning mechanism built in. In fact, it has two. One of them is called EMET, one of them is called Enterprise Certificate Pinning. The latter only works on Windows 10. The former works on pretty much every version of Windows. And so I'm pretty sure that I can adapt those systems to do what we want here, but I haven't actually coded that yet, so I have some work to do before the next Chromium release comes out next year. But the bigger problem there is that on GNU Linux, there's just no standardized method of doing certificate pinning. So if by any chance anyone here in the audience develops TLS implementations for GNU Linux, you really might want to consider adding some mechanism to customize what certificates are valid, even if it's just negative overrides, or even if it's just adding public key pinning. That would be good enough for what we're doing, and it would help a lot of people. Over on the Mozilla end of things, though, Mozilla actually does appear to recognize that this is a use case that matters, and they've actually expressed a tentative willingness to merging code that would actually add a browser extension API for customizing TLS certificate validation. And this is awesome because clearly they recognize that being able to customize how things work is an important part of free software, and they're not trying to, just play nanny with the user. So that's good. And I want to especially thank David Keeler, Andy McKay, and Andrew Swan at Mozilla for answering a lot of questions I had while I was writing a patch for Firefox that would implement this. That patch is about halfway done, maybe a little more than that. I'm planning to submit it upstream to Mozilla, so maybe in the foreseeable future, people who use Mozilla-based browsers will actually be able to just install a browser extension, and then they'll have Namecoin TLS validation working without any of this ridiculous dehydrated certificate magic that we're doing for supporting Chromium. But in the meantime, if you want to play around with the code that we've produced for using Chromium on Windows with the dehydrated certificates, it is available right now. It's released. It works. So go to namecoin.org and go to the downloads page. Click on beta downloads. You want the NCDNS for Windows installer. Oh, and if you want to test it, you can just go to nf.bit, which is the Namecoin forum, and if you have NCDNS for Windows installed, that will actually work, and it will validate the TLS certificate properly. And yeah, as I said, if you work on TLS implementations, please help us not use insane stuff like dehydrated certificates. We don't like doing that kind of magic. We were forced to. So that is all I have for you. I'm happy to take questions. And in addition, if you want to contact me privately as well, I'm going to be here at the Congress. You can also email me. Hopefully my Namecoin t-shirt will make it obvious where I am. So yeah, thank you.
I got one myself. Jeremy, thank you very much for this very nice talk. Technical as it was, you explained very good the pros and cons. Is my understanding right that the negative override is not yet implemented?
The negative override is implemented for Chromium on Windows. It's actually implemented also for Chromium on GNU Linux, although we don't actually have an automated installer for using the positive overrides on GNU Linux yet. So right now we're only advertising Windows support, even though you can get GNU Linux support to work if you're persistent. The problem with the negative overrides right now is that they will stop working silently once Chromium releases the version that kills HPKP. So for now it's safe, but when you upgrade Chromium eventually it will stop working, and that's why I'm planning on re-implementing that using the built-in certificate pinning that Windows has. I mean, I don't expect that to be incredibly hard, but on the other hand, it's Microsoft. They do strange design decisions. So we will see how that goes. I'm hoping to get on that in the next month or two. But in the meantime, until Chromium ships the new version that kills HPKP, it works completely out of the box right now, at least if you're using Chromium on Windows.
Okay, understand. Thank you. So I have 3 more questions for Jeremy. In the meantime, you can think about questions too. And are you ready for the hot seat? 3 hot questions.
Sure, why not?
So you say it's Namecoin, but why is it not Namechain? I think it's closer to the blockchain than it's to the Bitcoin.
That's a totally fair question. Interestingly, originally, when the Namecoin project was being designed initially, it was called BitDNS. And at some point, okay, so BitDNS was originally just sort of a proposal / design. It wasn't an implementation. and the person who actually implemented BitDNS into a working production-ready system that had a production blockchain. His name's Vincent Durham, although that's an alias, not his legal name. He decided to call his implementation Namecoin, and I honestly don't know why he chose that. It has caused a lot of confusion because a lot of people think, oh, Namecoin, that sounds like a really good investment vehicle for making me loads of money when my coins go up in value. And I mean, you know, we're okay with people buying Namecoins if they really think it's a good investment, but we don't view that as the primary use case. We don't cater to that use case much. So yeah, that said, I think one way you could argue that the term Namecoin is accurate is that the names in Namecoin actually are just special coins. They're special coins that have a monetary value of 1 name cent, and they also have some extra data at the beginning of their script pub key field, and that extra data includes some special opcodes which tell the Namecoin system this is a name coin as opposed to just a coin. So yeah, you could argue about whether it's a good term from a marketing standpoint, but yeah, point taken.
Thank you very much. The next question is about how many developers are there and how do you guys work? How do you work remotely together? What are the tools that you use?
Yeah, so every time I get asked how many developers we have, I tend to give a different answer each time due to the fact that as a mostly volunteer-run free software project, we do have people, you know, either start participating or stop participating or take a break, things like that. If I had to come up with a number right now, I'd say probably we have like 7 or 8 developers who work on stuff regularly, to varying degrees of participation. So, you know, we're a lot smaller than Bitcoin, obviously. We're even a lot smaller than something like Monero. That said, I think as a team we work pretty well together. We generally have a fairly cohesive vision of what kinds of functionality we want to see. We may of course disagree about exactly how to get there, but we do work together pretty well. In terms of how we communicate and stuff like that, we have a matrix channel, which is bridged to IRC for people who prefer IRC. Most of the communication happens via that. Obviously, we use GitHub and stuff like that as well. But yeah, things actually work out pretty well, given that we almost never see each other in person. There's a Namecoin developer here in addition to me. I first met him in person yesterday, even though he's been involved with Namecoin for many years. So yeah.
Your program language is Go then, is that correct?
The implementation of the Namecoin to DNS bridge is in Go. The Namecoin core client, which does all of the blockchain consensus stuff, that is in C++. To be honest, personally, I wouldn't be too opposed conceptually to moving everything to Go. I enjoy Go a lot more than C++. The problem there is that since we're a fork of Bitcoin and we merge lots of changes from upstream Bitcoin core, that produces problems if we deviate too far from what the Bitcoin community uses. And right now, the reality is that in Bitcoin land, the dominant implementation is Bitcoin Core, which is C++. So we're stuck with that for that purpose. But for all of the projects that are completely our work, like the Namecoin to DNS bridge, yeah, we're using things like Go, occasionally Python, just because those seem to be a lot safer than C++ or C.
Cool. Thank you very much.
Thank you.
Any questions from the audience? Well, please come here. I will be standing there.
Hi, thank you for the talk. Very nice talk. Just one question. I was wondering how difficult would it be to rewrite the Namecoin chain, and would that be dangerous for the CA for this application?
As in rewrite the chain, you mean as in like a blockchain reorganization?
Yeah, and like take over the majority of hash car power and
Right,
like
51% attack. Okay, yeah.
something like that.
So right now, Namecoin is relatively resistant to that because it's merge mined with Bitcoin, which basically means that Bitcoin miners can just add some extra software to their mining rigs and then they get some Namecoins effectively for free. And so there's a lot of Bitcoin miners who are mining Namecoin. And in fact, there was a rather hilarious incident a few weeks ago where, so as you know, there is a hostile hard fork attempt of Bitcoin, which they call themselves Bitcoin Cash. Some people call them Bcash.
Bcash.
So they actually stole a lot of hash rate from Bitcoin short term. And while that whole incident was happening, Namecoin actually ended up with more hash rate than any other cryptocurrency, including Bitcoin.
Woo!
And the reason for that is that all of the Bitcoin miners were mining Namecoin as well, but all of the Bitcoin Cash / Bcash miners were also mining Namecoin as well. And so we actually had as much hash rate basically as the Bitcoin and Bitcoin Cash / Bcash miners combined.
So you're the real Bitcoin then.
I know. Samson Moe said that on Twitter. It was hilarious. He said, "Oh crap! Now Namecoin is the real Bitcoin."
Thank you.
Thanks.
Thank you very much. I have two questions. First, did you consider registering a top-level domain, the .bit, as a TLD? That wouldn't solve, of course, all the TLS issues, but at least compatibility.
Yeah, okay, so this is an interesting question. Generally speaking, the registration process for GTLDs, generic TLDs, through ICANN requires that whoever is registered as the operator of that GTLD, they need to comply with trademark takedown policies. And as a decentralized system that's using a blockchain, we're not able to comply with ICANN's trademark rules. If someone is squatting on a trademarked name, well, that's too bad. There's nothing we can do about it. And so we weren't able to go that route. Also, it would cost a lot of money, which would also be kind of prohibitive since we're a small free software project without much funding. Although I should give a shout out to NLNet Foundation. They are funding us at the moment. So if anyone here knows people from NLNet Foundation, please tell them thank you for supporting awesome stuff. But there is an extra procedure that could be done instead of a GTLD registration. And this is called an SU TLD, Special Use Top-Level Domain. The idea is that you can get a top-level domain registered as not belonging to the DNS. It's for special use only. And we actually tried for quite a while to get .bit registered as a special use top-level domain. There were some political incidents there that I don't want to go into detail on, but long story short, Tor was able to get .onion registered as a special use top-level domain, but we were not able to get Namecoin registered at the same time. We are continuing to pursue that option. We're hoping that maybe that'll happen at some point, but yeah, for the moment, we're not able to make that happen short term. That said, as far as I can tell, it's extremely unlikely that ICANN would have any interest in issuing .bit as a GTLD to some random person who wants to steal it from us. From everything that I've seen coming out of ICANN, they recognize that if they were to issue a top-level domain that is already in active use elsewhere, that would be disruptive enough that they really wouldn't want that disruption to the internet ecosystem. So, I mean, short term, it's not really a huge problem that we're not officially registered, but we would like to fix that anyway, and we do plan to keep pursuing that.
Okay, thank you. Second question is, I first got into Namecoin a bit when I was mining myself back in the day when it still was profitable to do that. And then there was a thing called dual mining, where you mined Namecoin simultaneously with Bitcoin, right?
Yeah, merged mining, yeah.
Yeah, merge mining. But I think today it's not really supported by a lot of pools to do that. Do you have any effort to evangelize that to other pools so they can maximize profit and the hash rate?
That's a good question. We have done some effort to ask pools to mine Namecoin since they're mining Bitcoin already anyway. But in practice, it's turned out that we actually don't end up needing to contact pools about that, just because empirically it looks like we seem to keep going up and up towards 100% of Bitcoin miners just on their own, because the Bitcoin miners have realized that mining is so competitive now that if they don't mine Namecoins, they're losing out on money that might affect whether they break even. Mm-hmm. And so, you know, we're always happy to talk to miners and give them tech support if they're having trouble setting it up. But in practice, we've found that we don't actually need to actively evangelize. They tend to have an interest in using Namecoin on their own. That said, I should point out that it wasn't always the case that was true. Up until about 2 years ago, F2 Pool had a majority of Namecoin hash rate all by themselves. And obviously that's kind of problematic. It meant they could have attacked Namecoin at any time. That's no longer the case. They now have a relatively small hash rate percentage. But we were concerned about that, of course. We knew the F2 Pool people because they actually funded Namecoin development for a couple of years. And so we were pretty sure they weren't going to attack us and ruin their own investment. But even so, that's not the ideal situation to be in. F2 Pool also did help us out tremendously when there was a fairly interesting emergency that happened. People here may or may not know, a couple years ago, Peter Willa from Bitcoin dropped a 0-day on the Bitcoin dev mailing list that basically described a way to cause a chain fork by taking advantage of an OpenSSL bug. And Bitcoin had already patched it, but Namecoin hadn't yet. Patching it required a soft fork. And as soon as Peter Willa dropped that 0-day, we started contacting all the miners and said, hey, you need to upgrade and activate that soft fork as soon as you can. Well, a soft fork takes 95% hash rate to activate. We were able to get 92% of the miners to upgrade. The rest we had trouble contacting quickly. And so finally, we were like, okay, this is not good. And then F2 Pool contacted us and said, hey, you know, since we actually have a majority of Namecoin hash rate right now, we can just unilaterally activate that soft fork for you and just reject any block that doesn't advertise support for that soft fork. And we were like, okay, that's a really, really bad precedent to set. But at the same time, we do not have any other options. We'd really rather have that happen than have someone cause a chain fork that's really hard to recover from. And so F2 Pool did that, and a day later, the soft fork officially activated. We reached 100% of blocks, and so that solved itself because F2 Pool actually helped us out. So, you know, given that, we were pretty sure they weren't going to attack us. But at the same time, it's good that now that can't happen again. Now, I think the largest mining pool that mines Namecoin has something like 21% of Namecoin hash rate or something along those lines. I haven't checked the numbers recently, but it's a lot lower than 50%.
Thank you.
Thanks.
That was amazing, huh? Good questions.
Yeah, those were good questions.
Jeremy, if anybody has more questions, where does he find you?
So I can be found usually near the Monero assembly, which is somewhere back in that direction. And if you can't find me there at the Monero assembly, you're welcome to email me. Although I should note, I don't actually have access to my primary email account while I'm traveling due to the risk of having stuff stolen or something like that. I should mention that a couple of years ago I got an email from Twitter saying, hey, state-sponsored actors may have tried to compromise your account. I still don't know what state-sponsored actor that was, but ever since then I've been really careful when traveling internationally because I don't want to bring any of my standard crypto keys or passports with me. So, but yeah, you can email me and I'll get back to you when I'm back home in the US. Alternatively, if you want to contact me sooner than that and you can't find me at the Monero assembly, you can join the Namecoin channel on Freenode or the Namecoin Matrix channel and just ping me there. I think I have 3 usernames logged in there. Ping them all, and I will hopefully notice that and get back to you fairly soon. So hopefully that's enough options.
Cool. Thank you very much.
Thank you.